All right, so it's recording now. So what am I gonna do? I'm gonna put a noble metal into the nitric acid, watch it react. Here we go. We got an easy source of noble metals right here, and plunk. Is the copper gonna react with the nitric acid? It is, pretty quickly. Well, it didn't do anything with the hydrochloric acid. What's happening to it? It's generating, they call that evolving a gas. That's a good sign of a chemical reaction, producing a gas.
What kind of gas is
What? Okay, that's a very good question. Well, first of all, what color is that gas?
Brown.
Brownish orange. Is that a good color to have in the sky?
No.
This is the color of a lot of pollutants that we get in our sky. Well, I'm only making a few grams of it right here. If it's a factory, a lot of factories churn this out by the ton. Could you come back a little later because we're doing a demo? I'm sorry. Then a lot of factories churn this out by the ton. And sometimes if you look at the sky, and if the sky is brown, and it's not because of the dust from the Santa Ana winds, then this is what is in the sky. A lot of this. To make the whole sky brown, imagine. It's a lot more than a few grams of it. These are called oxides of nitrogen. There's actually several of them. We'll talk about later. There's 3 different ones. And they're all combinations of nitrogen and oxygen, which is funny because nitrogen is clear and oxygen is clear. You're seeing right through it, look. But oxides of nitrogen, they all tend to be brown or kind of brownish orange. So that's a pretty good reaction, and that's been going for a few minutes. And I've been waiting this whole time for somebody to interrupt me, but nobody's interrupted me yet. I think somebody almost did. Oh yeah, one other thing you might notice, it's turning kind of green. That's because a lot of compounds of copper are blue or green, kind of aqua colored. But that's not what I was hoping someone would say. Oh, it's too bad I'm recording this. The sound is good. What's the main thing that I'm overlooking? Come on. Think of the isotopes of Pennies lab. It smells, that's true. It doesn't smell good.
The amount of copper in the penny.
The amount of copper in the penny. How much copper was in that 2015 penny? That was a 2.4%. It's zinc, yes. So that was what we call a psych, kind of like in bingo. That was not the real noble metal. But we are going to really do it, so watch carefully. What do I need? What penny do I need if I want it to be made of copper? What year?
1948.
Okay, that would work, but anything before what? What was the year they changed?
1940. 2000. 1960.
Well, they changed in 1982.
1990.
So let me see. Let me get another beaker with a little bit of nitric. A little bit of nitric. About 15 milliliters, about the same amount. And this time, let's find an older penny. Oh look, so luckily I have some underneath. Oh yeah. See, these were zinc pennies. These are the copper pennies. Oh, I must have thought about this. 1974, there we go. 1974 pennies were about 95% copper.
Okay.
So, let's see how copper reacts. Now notice, that shouldn't have been a surprise to you what just happened. Although I expected you guys to remember what it was made of zinc. Because look where zinc is.
Oh God.
Zinc, of course, is going to react with any acid, even hydrochloric. So that shouldn't be a surprise. But let's see if we can really get, actually, do you know what I'm going to do before this? I'm going to fish out what's left of that little penny in there. I'm going to fish out what's left of it so that we can pass it around later once I've washed it before it's gone. Because there's not much left of that little penny. So I'll wash it off and I'll take it around and show you at your lab station later. That was the zinc penny. Here is the real copper penny. This one is from 1974. It's 95% copper. So this will be the real debasing of the noble metal. Drop it in. So compare the two reactions. Is it the same as the zinc? Please unhand it, or unhand them. Is it the same as the zinc? Kind of, but is it as fast as the zinc?
No.
Definitely not as fast. Is it changing the color like the zinc did? Yes, but is the color the same? Well, let's see. Let's see if it winds up the same color. Is it producing that orangish brown gas?
Yeah.
Yes. So the same kind of product, oxides of nitrogen.
Now it looks red.
And now that I've taken the first penny out of there, I thought we would try something new, something I've never tried before. What's that country north of us? If you go far enough north, like Oregon, Washington. What's that country up there? Oh, it's La Cañada. Up in La Cañada, they have a penny too. I wonder what they make their penny out of. Do you think you're going to be able to tell what their penny is made of? I haven't even researched this, so I'm not even sure myself what Canada makes their pennies out of, but we should be able to tell by the speed of the reaction. So this is something I want you to add to your lab report. By the way, we didn't do this in any other periods. They're going to just see this video for it. But let's see what the Canadian penny, which has a queen on it. Well, I'm an anti-monarchist, so this is fine for me. Let's plop it in. This is still nitric acid, by the way. Even though it reacted with the zinc, there's still enough nitric in there. Let's not worry about that issue. Let's plop it in.
Jesus.
So what would you guess? Looking at that, don't say it out loud because this is a video. I gotta show other periods. I'll have to turn the sound down. Don't say it, but think it. I wonder which metal makes up most of a Canadian penny. Don't say it. And then this will be something you can add to your lab report. I've never done that before, but I can tell right away. I know right now. I don't need to look it up. You probably don't need to look it up either. If I were to leave it in there for just another couple minutes, there wouldn't even be a penny left. So I'm going to fish it out while it's still there, if I can get it, if it is still there. And then, I can't see it.
It's gone.
No, it's in there somewhere. I'll get it, because it's still reacting. The reaction would die down if it was that. Oh, there it is. There it is, come on. Got it, got it. Got it. Okay, so, yes, it is hot. Good point. That leads us to endothermic, exothermic. I was going to talk about that tomorrow. That's a very good observation. So I'm putting this penny in here. Right now it's covered in nitric acid, but I'm going to rinse it off thoroughly before I take it around. You won't get any nitric acid on you, and you'll see what has happened to these pennies. And we are going to now do the nitric acid, super nasty acid in this bottle here. Does things no other acid will. It's a strong oxidizer. Okay, we're going to react it with the zinc penny, which we've already seen happen. The zinc penny, you see what happens to the zinc penny, we know that. The copper penny, okay, this is a 1983 penny, this is a 1973 penny, okay. We know what happens to the copper too. It's a noble metal. Look up here, the noble metals, but we got it debased. Now we're going to see what happens with the 1943 penny, kind of just for fun. We should know what's going to happen with that, because a 1943 penny is made of steel, like Superman, and steel is iron, which on the activity series, look, is right, I don't know if you can see that down here, it's just below zinc, so that's kind of what we'd expect, but wait, it has carbon in it. Interesting that steel is not even completely metal. Steel actually contains non-metal. Interesting. Sometimes 2%, okay, carbon to reinforce the steel. And just to make things interesting, we're going to actually react a little bit of silver. It probably won't focus that close. A little bit of silver, and just see if that will react. Another noble metal, even more noble, let's say, than copper, even lower than copper on the activity series. So that'll be the other thing. I'll try to put them in at about the same time so we can have a fair fight once again, like we did last time. And I'm gonna plop them one after the other. Zinc, okay, 1983. Okay, steel, 1943. Copper, 1973. And, bye-bye earring, okay, silver, argentum, like little Argentina. Let's see how these go. So look at the reaction rates. It's interesting that it might not have been what we predicted. what you might have written in your lab report already. Okay, obviously, once again, the clear winner, producing all these oxides of nitrogen. Okay, all of these oxides of nitrogen, which I took off the board. Okay, one that I didn't have last time, I was going to bring out. One that I did not bring out last time, we already mentioned that nitric oxide is produced. Well, nitric oxide, in the presence of regular atmospheric oxygen, often winds up producing some ozone. Okay, ozone is an allotrope of oxygen, O3. Okay, and ozone is different from regular oxygen. When I say oxygen, I mean this. Okay, ozone is O3. Okay, so we've already seen the zinc and copper react. Interesting that the 1943 penny is reacting less than we might have predicted. You might want to back away slightly. Okay, we don't want to be exposed to too much of these oxides of nitrogen. Okay, but let's keep it running and we'll see if we can get the steel to react, and we'll see if we can get the silver to react. Okay, another noble metal. This is the thing about experimentation, is it doesn't always match your prediction. So we're just gonna see what happens. Gotta say fun. Thank you for helping me. I'm just gonna keep watching it and see if there's any reaction. At this point, it's not. It might be tarnishing. I'll take a look at it. I'll fish it out. Looks like the silver is tarnishing. It's hard to get close with all these fumes. But I see some green in there. And I see a discoloration in the steel one. Okay, but clearly not reacting at the rate we would have predicted based on iron on the activity series. Look where iron is. Okay, look where copper is, and yet the copper is reacting more. Another factor that we should consider is that the steel penny was the only penny ever made, only coin ever made that doesn't contain copper. Okay? And even the old penny did contain a little bit of zinc. It was kind of a bronze alloy. So maybe the zinc got the copper started, you could argue that. Okay, interesting that the other coins, the nickel, the dime, the quarter, are made mostly of copper, and people don't think they are, whereas the penny is made 97.5% out of zinc these days, and people still think it's made of copper. So it's almost the reverse of what you think. It now costs more to make a penny than a penny is worth. It costs around 2 cents to make a penny. So the government loses millions of dollars every year just making them. Okay, I'm going to keep an eye on this. So obviously, clearly the reaction with the steel is very slow. The reaction with the silver is even slower, although there is a discoloration. So what I'll probably do is in a little bit, by the way, there goes the last of the zinc penny. The last little bits, those are fizzing around there. That's the last, boop, that was it. That was the end of the zinc penny. That was the 1983 penny. Okay, the copper penny isn't going to last too much longer this time. I'm just going to let it go to completion. Let it go bye-bye. And then we'll see how much reaction we get with the other two. So was that what you predicted with the 1943 penny? Is this what you expected? Maybe. And nitric acid, super nasty acid. Does things other acids don't. Okay, has the hydrogen ion, which makes acids, that's why hydrogen's on the activity series. These usually react with acid up here. Okay, but it also has the nitrate, the nitro group. That's found in most explosives. It's found in nitroglycerin. Okay, saltpeter. And it's found in ammonium nitrate that we used in the cold pack lab. We're getting down to the end of the copper penny. Notice how it's taking longer. That makes sense. Okay, see the bluish color, the greenish color? Copper compounds generally produce aqua blue or green colored compounds, even though copper itself, as you know, has that characteristic sort of orangish color. Copper compounds, on the other hand, are generally known to have a blue or green. We notice that in a lot of minerals that contain copper. Alright, so, got the tweezers. I'm gonna fish out what is left, most of it. Got a little woof, silver. And it's hard to stand above nitric acid. It's a nasty stuff. Okay. I might have to put my phone down to do this with 2 hands. Steel penny doesn't look any different, honestly. Pretty much as good as new. I'll take the mass to see if any's been lost. Still see everything, still read the small print. Looks just like it did originally. The silver earring does look damaged. I'll wash it off and I'll take the mass of it as well. Alright, enough of being penny ante. Now I'm gonna nickel and dime you. Nickels and dimes, I wonder how they react. We've already seen pennies, we've seen the old penny, we've seen the new penny, made of zinc and copper. I forgot to show some periods about nitric acid, that it really is an acid. So let me just show you, universal indicator. If I put a few drops in, look at the one in the middle. That's pretty red. Right away, just a couple drops, pinkish at this point. That's red. Okay, that is a good acid. Plus, it's got the nitro groups to boot. Here goes the nickel. Okay, 5 cents, it says on there. That's useful to know. Here goes the dime. 1 dime, it says on there. That's not as useful. If you don't know what a dime is, you'll never figure out what that means. It doesn't say 10 on there. What? That's really useful for people from other countries. Plop it in. Okay. Wow, that's interesting. Nitric acid even reacts with universal indicator. Not a lot of things react with universal indicator. That's funny. And then you can tell by the color and the speed of the reaction what they're made of. You're probably guessing, which one does this look more like? Does that look more like what we saw with the old penny or the new penny? They both gave off brown gases, but the color was a little different and the speed of reaction was a little different. So does that look more like the copper penny or does that look more like the zinc penny? Interesting. Let me see if I can fish out, let me fish out the dime first. It's still reacting pretty strongly. Not gonna let it finish. There we go. There goes our little dime. There goes our little, where's our little nickel? Plug nickel. Gotta fish it out of there. It's gotta be, there it is. We got the nickel. So what I'll do is, all right, I couldn't resist doing it. What about a quarter? Same thing, nitric acid, plop it in. What are quarters made of? You can probably tell by the reaction, the speed of the reaction, how quickly The oxides of nitrogen are given off here, what it's probably made of. We already saw the dime, that's when I fished out the nickel. We've seen several different pennies, even Canadian pennies. And you can probably guess that that's kind of like the nickel. That's kind of like the dime. So surprisingly, nickels, dimes, and quarters are made of the very material that most people think pennies are made out of, and yet pennies are not made out of it. How ironic. Let me fish it out. Wasn't in there as long, wasn't in there too long, but we'll see what difference that makes.